pitop.
DNA is an amazing molecule. Beautifully shaped as a double helix, it carries all the information needed to make up a human. An army of proteins reads, interprets, and copies information in DNA. However, there are regions of DNA that contain no information and instead consist of meaningless, repetitive regions. For example, in one place, 3 DNA letters, G and A, are repeated several times. We call them GA repeats. Most people don't have many, less than 30 repeats. However, some unlucky individuals may have hundreds or more, and they develop incurable disease, Friedreich's ataxia. They start to have a disturbed gait as teenagers, completely lose the ability to walk by the age of 30, and typically die from heart disease before they turn 50. So why are many GA repeats so harmful, you may ask? Well, DNA is like a text, and it is really hard to follow. Really hard to follow. Really hard to follow. Really hard to follow. Really hard to follow a text that repeats itself. Another challenge, GA repeats oftentimes do not form a double helix. Instead, they form a triple helical DNA, which is something that proteins have no idea how to deal with. So in my PhD, I'm trying to find a way to make a long and dangerous GA repeat short and safe. To do that, I use an organism that closely resembles humans, baker's yeast. You may be thinking that yeast look slightly different than humans, but in terms of how they deal with their DNA, yeast are basically just little people. So I inserted over 100 GA repeats into yeast DNA and determined which proteins shorten it. I discovered that shortening happens when cells copy their DNA. A long GA repeat forms triple-stranded DNA that goes unnoticed by the copy machine proteins. Since they can't scan it, they just skip it and instead print out a much shorter sequence than the original. Using this knowledge, people now might potentially develop drugs that would facilitate the skipping mechanism, and hopefully, one day, no one's going to have more than 30 GA repeats in their DNA. Thank you.